Hello, everyone, and welcome to the Tackling Heat Stress in Fruit Production Innovative Strategies for a Changing Climate webinar, presented by Cultiva. This discussion will explore the science of heat stress in fruit crops and introduce innovative strategies like strengthening plant cuticles to protect yield and quality amid rising temperatures. I'm Hillary Wynn, the Custom Content Manager for Meister Media Worldwide, publisher of American Fruit Grower Magazine, and I'll be moderating this webinar. This webinar has been approved for 0.5 CEU credit in crop management from CCA. To receive credit, you must watch the entire webinar. An attendance notification will be sent at some point during this webinar, and you must respond to receive credit. If you respond once the webinar is finished, you will receive an email with the QR code for reporting your credit. You simply scan the QR code and submit it. Please do not close your web browser before the webinar has ended completely, or you will not receive the email with the QR code. This is also for the viewers watching the archived webinar. Now I'd like to go ahead and introduce our speakers. Dr. Antonio Heredia, Dr. Eva Dominguez, Craig Hornung, and Tiago Moraes. Tiago is a professor in the Department of Molecular Biology and Biochemistry at the University of Malaga. He is a chemist specializing in physical chemistry. Antonio has carried out research in the fields of plant sciences, biophysics, and polymer science. His main lines of research are the physiochemical characterization and biophysics of the plant cuticle, the study of fruit quality and disorders such as cracking and microcracking of fruits, and the molecular mechanisms of plant cuticle synthesis. Eva is a botanist specializing in plant breeding and plant barrier biopolymers. He is currently a scientific researcher at the Institute of Subtropical and Mediterranean Horticulture, La Mayora. Her research is based on the study of and shares a basic research approach combined with an agronomical perspective to understand how the cuticle is modified during development in response to environmental and growth conditions and its implications for fruit quality and disorders such as cracking and microcracking. Craig has been involved in agriculture his entire life, growing up on a family citrus farm and earning a BS in agricultural engineering from Colorado State University. A pioneer in ag technology development for over 30 years, he co-founded Soil Solutions Corporation. Craig has held product management roles at T-Systems International and John Deere Water, helping advance remote sensing tools like CropSense and Field Connect. He also serves as vice chairman of the East Kawa Groundwater Sustainability Agency and is one of the original sumo citrus growers. Tiago is a North America sales manager at Cultiva, where he oversees sales strategies while supporting the sales team in achieving their objectives. With extensive industry experience, he plays a key role in bringing innovative solutions like Parka to growers, helping them enhance fruit quality and maximize marketable yield. At this point, I will turn the webinar over to our speakers. Antonio, Eva, Craig, and Tiago, welcome.
Thank you. Thank you. Thank you, everybody, for joining us here today. As she mentioned, today we'll be discussing tackling heat stress in fruit production and innovative strategies for a changing climate. We have the presenters that you guys just got an introduction here, Dr. Antonio, Dr. Eva, Craig, which is a very experienced citrus producer in California, and myself will be bringing some insights from the Parka products, from the line of products from Cultiva. Today, our goal for our discussion today would be to understand more about the role of the plant cuticle and how it influences fruit production and fruit quality, how the environmental conditions can impact those plant cuticles and fruit cuticles and the fruit production itself, and what approaches can we use and what tools do we have to effectively help fruit production and crop protection from such environmental conditions that we'll be talking today. Again, thank you very much for everyone for joining us, and I'll turn over to Dr. Eva and Dr. Antonio.
Thanks, Tiago. Good afternoon, everyone. I'm going to talk a few minutes about the plant cuticle, the basis of the plant cuticle. As you know, and you see in this slide, the plant cuticle can be considered as the frontier, the interface between the plant and the environment. The plant cuticle covers all the aerial part or leafed, fruit, even the non-lignified stems. As you can see in the right side of the slide, the cuticle can be considered as a modification of the polysaccharide epidermal cell wall. There are two main components of the plant cuticle. The first, the waxes. The waxes are in low amount in all cuticle, but they are very important. Waxes are insoluble, and they are deposited in the outer part of the cuticle. They are the epicuticular waxes, or inside the cuticle. They call it intracuticular waxes. The main function of the waxes is as barrier against the water loss. The cutin, in orange in the slide, is the main component of the cuticle. Inside cuticle is around the 80% of the total of the cuticle. It's an insoluble polymer. It's like a biopolyester. We can say something sometimes that the cutin is like a bioplastic it's bioplastic, very flexible with very nice properties. Interesting in this slide to note the presence of other components of the cuticle. They are the phenolic components, phenolic compounds. They are in very low amount, sometimes 2, 5, 7%, more or less, but they have a very good function, very important function. The sunlight interacts with the phenolic in the cuticle. You can see in this second slide, the cuticle can be considered as a hydrophobic layer. There are 7 pictures of 7 different cuticle, cross section, microscopic picture, olive, grape, also fruit. You can see the big difference in the thickness of this kind of cuticle. Orange, in the case leaf, I remember the leaf of Citrus aurantium, and even for tomato, the difference between the cross section, the thickness between the cuticle of the fruit and the leaf is very, very different. In some cases, the fruit around 7, 8, 5 microns. In the case of the leaf, is under 1 micron. The cuticle is subjected to external environmental and internal conditions. In this slide, we can see the main interaction of the cuticle. Because the wind, there are mechanical damage also via insect or fungi. The water interacts with the cuticle, of course, the light, the temperature. For this reason, we have interesting property of the cuticle. But even for the internal condition, we can consider the pressure. There is a very important the growth of the fruit on the leaf, and even in the plant internal water status, water stress. For this reason, after this slide, we can consider a summary of the function of the plant cuticle. They are very important. The cuticle controls water loss from internal tissues. Very good property, mainly because the waxes is the main component in this case. The cuticle protects plant from high and low temperature. The cuticle protects from UV radiation, very important. The optical property of the cuticle are now in our laboratory. We are investigating the photoprotection of some compound of the cuticle against the UV radiation. The cuticle defends against pathogens. The cuticle also has interesting mechanical property, gives mechanical support to leaves and fruit. Also contributed to the fruit color at glossing, at the gloss, and also play a role in produce post-harvest, in the case vegetable, fruits, etc. And now I think I remember I give my turn to Eva.
Thank you. So as Antonio was saying, the cuticle is very important for since it gives mechanical support to fruits and vegetables. And in this slide, we can see how the cuticle of we're seeing a bell pepper with microcracking. And in the non-cracked region, we have a cross section where we can see in orange the cuticle as an intact layer. Then if we go to the lower part, we see microcracking and how it looks like when you do a cross section. You realize that the cuticle in orange is completely broken, cells are distorted, and if you see at very, very high magnifications from the surface, you see a tremendous crack. In the middle, we will have teeny tiny cracks that most of them cannot be seen from the naked eye, but you realize that the cuticle is also broken. The importance of this slide is that these pictures were not taken 5 minutes after the cuticle cracked. Those cracks maybe happened 2 days, 5 weeks ago, and the plant was not able to seal the crack, or at least to seal the cuticle. And that is a very important thing, because once the cuticle breaks, the plant is not able to seal it and to rebuild the cuticle. And these broken sections, despite the plants have tried to seal it as best as they can, they will still be points of tremendous water loss. As we mentioned, the cuticle is not only important for mechanics, but in the case of tomato, it gives a fruit color. If you compare the cuticle of a red tomato and a pink tomato, you realize that the cuticle, as you can see underneath, have a very distinctive color. Red tomatoes have orange cuticles, that's why we see them red, whereas pink tomatoes have very translucent cuticles. That's why we see them as pink. And that made us realize that the phenolic compounds that produce these changes in color are extraordinarily important for mechanical reasons, because they confer mechanical resistance. As you can see in these diagrams, in order to break an orange cuticle, you need to apply a lot of force. The cuticle will not deform very easily, and you will need a lot of strength in order to break it. However, in a pink tomato, the cuticle will yield very easily and will break also very easily. And this is not only important in tomato, but also in other crops, because as Antonio was saying, although this orange color is not present, in other cuticles, phenolics are present, and as having more phenolics is important for to reduce cracking. That's also true for polysaccharides that also confer mechanical resistance. Okay, the cuticle is also important for fruit gloss. Here we can see the differences between a tomato that is particularly dull, and that is because the presence either of microcracks that are not visible to the naked eye, or the presence of tremendous amounts of waxes that give the fruit a very dull appearance. Whereas shine or glossy tomatoes are basically due to a very smooth surface or very organized structure. Although we have said that the cuticle, once it breaks, it will not be able to seal it, to be resealed, that doesn't mean that the cuticle is not changing throughout development. Here we can see how the cuticle is growing in it as the tomato grows. From a very, very thin, almost naked, impossible to see to the naked eye, cuticle in the very small fruit, to a much thicker cuticle. And interestingly, in tomato, as the fruit ripens, the cuticle degrades and becomes thinner. But the cuticle also responds to environmental conditions during plant growth. If we compare the cuticle of a tomato grown in winter or in summer, we realize that the amount of cuticle per square surface is extraordinarily different. And even if we compare under the same season, as for example, summer, we realize that relative humidity also has a tremendous impact in the amount of cuticle synthesized. When you have a very high relative humidity, the amount of cuticle is very small. When you have water stress, the amount of cuticle is increased. The cuticle is a porous membrane. That means it has small cavities, as we can try to depict here with these squares would be cuticles, and you will see some small cavities that are filled with water as relative humidity increases. Although the amount of water that the cuticle is able to take is very small, between 3 and 5%, that plays a very important role because the cuticle first retains that water with a lot of stress. It's not easy to remove it. And second, that water lowers the mechanical resistance of the cuticle, making it more prone to cracking. Let's think, for example, rain cracking, which would be a clear example of a cuticle that has taken water from the outside and become mechanically weaker. That's also important during storage. And that's why having fruits and vegetables with as reduced relative humidity as possible is important. And regarding temperature, the cuticle has two roles. The first one is the cuticle is able to absorb heat and cold from the outside and minimize that, that energy transfer to the interior of the cells, which means basically that the cuticle acts as a thermal insulator, trying to avoid the plant from suffering extraordinary heat or extraordinary cold. Of course, this is within limits. The second role that the cuticle has is, regarding temperature, is a transition between a solid state and what we have drawn here as a fluid. And this doesn't mean that the cuticle becomes liquid. No, it means that it changes from a very rigid structure to something that is extraordinarily dense and viscous, something more flexible. Let's think of a pavement of a road under a very, very hot summer day, that you feel that it's not as rigid as it usually is. Why is important this temperature? First of all, because the moment the cuticle becomes less rigid, it is mechanically weaker. Second, because when the cuticle is weaker, what you have is also a higher water loss because waxes starts melting, and therefore the barrier against water cannot be maintained. That transition temperature changes a lot between species and cultivars. Here we have an example of two tomatoes, and you have one where the transition temperature is at 30 degrees Celsius, which is 86 Fahrenheit, is a very high transition temperature, but the other one is at 3 degrees, 37 Fahrenheit. So if we were to storage these tomatoes at, let's say, 5 degrees, this one will have a very rigid, strong cuticle, but this one will have a much weaker cuticle. And I think now, to sum it up, I will give Antonio the word to finish explaining how this mechanical properties are extraordinarily influenced by water and temperature.
Thank you. This is the last slide of our common presentation. It's very important, and the information, from my point of view, is very direct, very simple. There is a very strong relationship between the mechanical properties, the hydric property, and the thermal properties of the cuticle. Very strong relationship. Any modification in each of these topics has significant influence in the other topics. For this reason, the fluxes of matter, the flux of water, the flux of temperature is critical to understand the role of the cuticle in this condition. For this reason, this slide, from my point of view, is a good summary of all the property presented in this presentation. Thank you very much.
Thank you, Antonio and Eva. So I'm going to go through and give you a quick overview of our citrus production and how the change in climate and heat stress and how it affects the trees and what things we're doing here to basically combat that. So we farm here in the San Joaquin Valley. This is actually a picture of some trellis citrus, which is kind of the new thing that's coming in. Higher density trees to get greater production from same amount of land. But here at the Citrus Division for AC Foods, we farm in multiple counties here on the east side of the San Joaquin Valley here in California. We produce a variety of citrus. One of our signature crops is a sumo citrus. If you guys have had that in the store, it's a really good, spectacular eating piece of fruit. And we also, I have my own farming operation with my brother that we've had since '86. So we're fully immersed in the citrus industry. So with the changing in climate, we also have a lot of regulations that we have to contend with here. And we farm mainly in the East Cahuilla GSA, Groundwater Sustainability Agency, and that has to do with groundwater groundwater issues. And so we have to be very careful on what we're putting on the crops, that we maximize the amount of water that we're using. We don't have any water to waste. The overdraft of the Cahuilla subbasin is substantial, and a lot of things are being put in place to help correct that. And irrigation is one of the big issues that we have to contend with so that we're not wasting any water at all. And so how do we address heat stress? You know, we look at the whole activity of the plant through all the different cycles that the fruit goes through, and what can we do to help maximize the tree's strength and health so that it can ward off the changes in climate that we're experiencing. You know, proper irrigation, monitoring, and scheduling is probably number one. We want to make sure that the tree is fully hydrated. We're not over irrigating it. We're not under irrigating it. We can change that throughout the season based on what we want to manipulate the tree, but the tree has to have a good supply of water and nutrients in order to ward off heat and heat stress. We continuously monitor the trees for a nutritional aspect. We look at all the irrigation water from a chemistry aspect to make sure that that is in the best form as possible. The fertility that we go through is continuous throughout the season. All those things really play into making a healthy tree. And of course, we look at the application of sun protectants at specific spots to help end up giving us a good piece of fruit at the end of the year. Because if you don't have a good piece of fruit to sell, it's all for naught. So on some of the stuff that we work on from tree health, of course, we do soil analysis, tissue analysis. We've done some sap analysis with quick soil, looking at what's actually what the activity is in the tree itself, not just from a dry matter basis. And that kind of gives you another window into what the tree's experiencing. We're doing a lot of soil biology work. Of course, we analyze all of our irrigation water. And overall, we have a very complete nutritional program that we work on for our trees. From the irrigation side, and also to maximize our water availability that we have, we use a lot of automation so that we're making sure that we're putting on the right amount of water at the right time, and we're not wasting any of that water, so that the tree gets the biggest bang for your buck from the irrigation side. The other thing about irrigation is irrigation really is a way to help protect your fertility. You can screw up your fertility very quickly by not watching your irrigation water. So in order to protect what nutrients you're putting in there, that they stay in the root zone so that they can get maximum uptake, you've got to really match your water to that area of the root zone so that you're not flushing those nutrients down through the profile. We have a lot of low EC water here because the water comes out of the Sierras. It's snowmelt water, and so when we look at the chemistry of that water, we basically manipulate that mainly with some dihydrate calcium sulfate so that we get a good area of water penetration into the soil profile so that we're staying at field capacity moisture and not saturation. That really helps the tree during periods of high temperature so that you have oxygen in that root zone and you're getting the maximum uptake with nutrients into the trees so that it basically builds strength of that tree. We do a lot of soil moisture monitoring. You can see that one of the graphs here so that we're making sure that we understand where our maximum root zone is and our activity within that root zone, and we're matching our irrigations and our fertility applications to where that zone is. We've done some work looking at the internal pressure within the leaf with some of the Yara sensors. It was very interesting to see how the tree rehydrates at night. That everything that we do, we always learn something. It may be a small point, but it's something that we can apply to the overall scheme of what we're doing. And in this graph, you can see that the trees were not getting hydrated. We had a lot of very warm temperatures. The morning temperatures were in the 80s, and going through the first part of that period there, it was really hard for the tree to hydrate. But then you look where the main arrow is, that early morning temperature broke, and you can see in that 12-inch level, we got a lot of stepping, a lot of activity in there, and the tree actually rehydrated. So the environment really has a big play on what the tree's doing, and especially when you're trying to grow that fruit. So we put all these together in looking at how can we support the tree, as well as getting the maximum amount of growth and protection of that growth that we're getting from these from all the citrus blocks. We've noticed in the last few years that there has been an increase in the amount of UV light, and that does have an effect on the sunburn on specific varieties. And so we want to make sure that tree is fully hydrated so that we can ward off any of that breakdown of the outside layer of the fruit, which basically makes it unmarketable. So leads us to this question: when does sunburn really start? You can see trees that have sunburned leaves in the course of the summertime, but from a fruit standpoint, a lot of the sunburn actually starts early when we get past petal fall, and that little piece of fruit is there. It's very vulnerable, and the UV can basically burn that. You won't see it, but you'll see it as the fruit grows, and then you'll end up with a $1 sign or a quarter size burn on that piece of fruit. So we start looking at what can we do to help protect the tree from sunburn right after we have bloom. So we're protecting the fruit, especially with our thrip sprays. We'll put in Parka to help protect that little piece of fruit so that it doesn't get burned. And we'll run that through the first part of the spring until we get into fruit drop. We'll do our foliar sprays, and the Parka makes it really nice because we can still go through and put our foliar nutrients on and not have to worry about washing off any of the sun protectant off the trees or the fruit. And then we will roll into putting on Surround, which basically is a kaolinite clay to help protect it through the summertime. But the early applications of material on that little piece of fruit is absolutely critical, and that's really where the Parka shines, at least for us. So we've done a lot of sunburn trials. We've looked at different materials. We look at when does the sunburn really occur, but you can see all the different issues that we have here with starts with a little piece of fruit, and then you end up with a lot of fruit that is unmarketable, and that is not going to do anything for you as a bottom line. So we want to make sure that we're protecting that fruit from the very start. So here's some of my observations that I've put together over the last 40 years. Quality water supplies are critical to where we're farming. And you can say that water's everything, but until you lose water or water goes away, it doesn't really hit you. But water and taking care of those water supplies is absolutely critical to us from a long-term aspect to make sure that we're still going to be a viable industry. I always schedule my irrigations to be as efficient as possible throughout the entire season. That is really critical to maximizing your water supply. We run maximum fertility to make sure that we achieve good management of our water. We're not wasting the fertility because we haven't done a good job with our water. Here we measure basically everything. You can't manage something unless you know what your parameters are, and you need to measure those so that you can manage that well. We grow the best crop possible. It may not be the biggest yield, but we want to make sure that we grow the best crop that we possibly can. Here in the ag side, we don't always get good press. And so I think it's important that we, as growers, explain to society of this land. We've been here for a long time, and we take good care of our trees and the land, and that's something that is really not communicated to society. And in addition to that, the general population has no concept of farming or where their food comes from, and that's a big hole to fill. We grow the safest and most abundant food in the world. And the number 9, which is farming is an art supported by science. There's always an art to looking at the trees and understanding what the trees are telling you and turning that into an action item. And the last one, because of the amount of regulation and all the other stuff that's being thrust upon us as growers, I think it's important that we elect statesmen and not politicians, because ultimately the regulations that come out of Sacramento or even from the federal government are not necessarily beneficial to us in the fruit production aspect. And with that concludes my presentation.
Thank you very much, Craig. Appreciate it. So I'm going to finish here this presentation. We're going to talk about ways to improve the cuticle and what tools we have and what we're doing here. This portion of the presentation today kind of got a lot easier for me after having Dr. Eva and Dr. Antonio go through this whole material, so I don't have to talk too much about this, but I want to reinforce a couple of things because that's the whole point, is to bring attention to how important the cuticle is for the plants and the fruit, right? It's something that gets overlooked all the time. And we're learning here today that it touched everything pretty much from water loss to uptake to, transpiration, nutrients, protection against pests and all those things. So we learned today, the characteristics, what's the cuticle, what's the axis, how it's formed, so we're going to be talking about this composed of lipids and polysaccharides, and all those things that Dr. Eva and Dr. Antonio already mentioned to you guys. And I'll explain how this ties into our flagship product, Parka, here soon. But again, like they mentioned, the roles of the cuticle is something that we always bring in our presentations to bring attention to these things. Restriction of pathogen infections, providing mechanical support to cell walls, to protecting UV radiation, to limit water loss and water uptake. All these things are extremely important for the function of a plant, especially when we think in environmental conditions that are getting harsher and harsher. So more than ever, the cuticle is playing a huge role in how this plant is performing and the quality this fruit's going to come out at the end of the cycle. So our solution, Parka, is a plant cuticle supplement. It was developed originally by Oregon State. At the time, the two scientists that developed this product were trying to create a product that was the closest as possible to the natural cuticle. So that's why you see on our formulation is composed exactly what we just saw the professor is explaining here. Phospholipids and polysaccharides is the exact same composition. So we're not coating per se just the plant, but we're fusing our own cuticle to the natural cuticle of the plant. And also, when we built this technology, there were some very important characteristics that was built in that made the Parka a very user-friendly and very effective tool to be used managing heat stress and all these environmental conditions that we're talking about. One, we learned today, how important it is to have the elasticity on the cuticle. So they made sure to have that present there with the polysaccharide compositions, so we can follow that plant and the fruit growth. And especially as Craig mentioned here, early in the season, you saw in the presentation as well, has the cuticle is really thin when that fruit set happens, and you have cell division, cell elongation happening at that time. There is exponential fruit growth that's happening, and the plants can't overlay enough cuticle to follow that. That's a very critical moment. So keeping the elasticity is very important. Being hydrophobic, we learned today, repelling the water away from those micro crackings, sealing those micro crackings as well is very important, especially when we're talking about, cracking like in the cherries or blueberries and other varieties is very important. Tank mix compatibility. Craig here just mentioned, being able to put Parka in a tank with your insecticides, with your fungicides, with your nutritional program. You can replace a surfactant. It's very tank friendly, so you don't have to have the cost of an extra pass just to apply a product. It just can catch a ride on your tank and be easily integrated into your spray program. Permeable is another very important characteristic, and we'll talk more a little bit here, but a lot of people think that every time you're talking about a cuticle, you're sealing everything. So Parka is not an anti-transparent. Matter of fact, I'll show you guys some data here. It allows, an increased CO2 exchange in stomato conductivity. So we're not working as anti-transparent, the opposite. We're helping that transpiration happen and the gas exchange happen. It's certified grass material. We're EPA exempt, is made of edible food grade ingredients, so we have no PHIs. You can spray at any point, and no restrictions there as well. And another very important characteristic is a clear material. So we're delivering all these benefits of this cuticle supplement without leaving any residue. There's a lot of crops and a lot of piece of fruit that can't be washed post-harvest, or even those that can be washed, extra wash can cause more problems than helping during post-harvest quality and storage. So being clear and leaving no residue is a very important characteristic for Parka as well. So I want to cover here is, my goal is, now that we understood more and we know more about the cuticle and how important it is and all the functions it has, to understand the mode of action of Parka. Because then you guys are way smarter than I am, and you'll find ways that this product might be a solution for you in your operation. So we basically have mode of action divided in 3 points. In the origin section, we'll be talking about is more of the mechanical properties of Parka. So when Dr. Eva showed those microfractures that happen during the fruit development, being able to seal those microfractures early to prevent rusting in ends, preventing cracking, to preventing fungal infections or bacterial infections that can use as a door, repelling water, and keeping that elasticity. So that's most of the mechanical portion, and also increasing the quantity of that cuticle on the leaf and the fruit that will help with things like the sunburn properties and UV radiation reflection and those things. The other part the other two parts here basically will be talking more about the physiological response on the plant, not much on the fruit itself. So if we're thinking in cell membrane stability, we learned today how important that is. Preserving those fatty acids that are there. Parka also adds to it, but by reducing oxidative compounds that will degrade those fatty acids, will preserve better and will have a better cell membrane stability. And also we have measured things like increasing of antioxidants that will help not only with the cell membrane stability, but also with color, if you think anthocyanins as one of them. The other portion in that we learned along the years and became more and more clear to us as we do more and more basic research was this improvement in photosynthesis. We got reports from the field back a few years ago that people will start seeing a response of the plants being happier, trees being fluffier was a term that was thrown out there, that they have more shoots, more laterals, more leaves. The apex were not defined as early. And we measure all those things, and how we see those is we see an increase in stomata conductance, we see an increase in CO2 exchange, and we also increase fuel fight and chlorophyll, which help harvest some of that excess energy and use that in the photosynthesis pathway. So then instead of trying to be overwhelmed by energy, now the plant is actually using that energy and promoting growth. So here's a little bit of a diagram that will show what we separate from fruit cuticle and leaf cuticle. Both will be dealing with abiotic and biotic stressors. When we're thinking in fruit quality, we'll be talking more about the fruit cuticle. So we'll be talking about sealing microfractures to prevent cracking, to prevent rusting, applications pre-harvest, like in stone fruit, that will help, from inking, or on the case of the sumos late in the season in the winter when they have some rain events and could have some markings that will happen on the fruit. So all these things that we're talking about will be related to improving the cuticle and the fruit, including sunburn reduction, as we learned from the professors here today, and Craig as well, mentioning that protecting that fruit early, giving the tools for that cuticle to be there, and reducing the amount of sunburn that you're going to have later on in the season. When we're talking on the leaf cuticle, this is more of the plant response to the main objective here today, which is the environment and the heat stress and drought and wind and high UV, high temperatures. So by increasing chlorophyll content, by enhancing that CO2 exchange, we're having more transpiration. When you have more transpiration, you're moving the sap that Craig mentioned that they were measuring. You're uptaking the nutrients that you're putting there. You have better water use efficiency. You have more photosynthesis. So all those components together land into a better performing tree that will lead you to better yield. So when you combine helping the fruit with the fruit finish and helping the plant to push that fruit, that's how you get to a better marketable yield at the end of the production cycle here. So I have some data points. We have many, many more that we'd like to share, but due to time, I just brought some of those that are more pertinent to this presentation and to this topic. But if anybody has any questions, feel free to reach out to us after this, and our team will go to you. But we talk so much about, the relationship of the cuticle and how it's important to have that cuticle. And we saw those photos that what happened when that cuticle is not present or it gets cracked or broke down. So this was a study done in Spain by Dr. Isabel, and we measured the quantity of cuticle on apple leaves here during the season. And you can see the total wax on the top graphic and the total cutin on the bottom graphic. And you can see a significant increment in that amount of cuticle that has been deposited on that leaf. As we learned today, Professor Eva mentioned, imagine if you have a leaf and you have your stomata opening and closing during a heat event to prevent loss of water, but now you have a leaf that is full of crackings and you're just leaching water out of there, and the plant, there's no way to regulate that because it cannot open and close like an stomata. So it's very important to keep the integrity of that cuticle on the leaves as well, not just on the fruit. And if you see, it correlates to the graphic on the right, which is the temperature was at the hottest part of the season with the lowest humidity when this data was collected. We talk about water movement and water uptake and sap flow, so we also measure those things. We use sap flow technology from Dynamax at the time, and we measure on almonds in California. And what we saw is throughout the season, there were many times where the plants that were, the trees that were treated with Parka had higher sap flow measured during the season. And that has yielded us to that and some other characteristics like helping June drop and other things. We have now a robust data set on almonds that we've been able to increase 2 to 3 up to 400 pounds per acre by doing some Parka treatments on almond itself. And then if we talk about water use efficiency, again, this is also done by Dr. Isabel on apple trees. And we have here treated trees and untreated. And you can see in the beginning of the season, they're not as different, but as the weather gets warmer and hotter, and also those leaves start degrading, losing the capability of chlorophyll content or having more microfractures and not being able to regulate water loss or water uptake anymore, you can see how the plants that treated with True Seal with Parka here have a better functioning as far as water efficiency. And again, so we're talking about all these functions, right? All these physiological functions that the plants are having this response when treated with Parka, because now we understand the role of the cuticle and how the cuticle touches in all those points. So we actually measure these things. So we measure net CO2 exchange, we measure stomata conductivity, we measure transpiration, and we measure photosynthesis basically, and even leaf water potential. And every time we've done this study, this was done also in Spain by IRTA Institute, and you can see that there's a significant increase on the plants that were treated with Parka. So then we learn all these things about our product. We learn about these things about our mode of action. We understand more of the physiology. We understand the pathways that we're working through. But now me and the sales team, like, how do we go out there and tell people that, hey, here's what our product is doing for the trees or for the plants, and conveying all this message. So it was a very difficult sales proposition, to come from a cherry cracking material as we were founded at the time. So one of the things we did is we went out there and we sprayed trees on first and second leaf with no fruit. So now we took the fruit out of the equation and we're only focusing on the performance of the tree. I actually have a really good video of this trial here. We have a drone that flew over and you can see, in real life as if you were there. But because of the format here, it was difficult to put the video. But you can see on the pictures here, on the right is the untreated, and on the left is the treated. Not only the treated had a better height, if you think of the top wire there of that trellis, which it wasn't always the case for us. The height of the plants were not much. There was difference, but not always as significant. But just the development of the canopy, that was unanimous. A lot of trials we done in almonds, we done in cherries, we done on apples, and many other crops, and is a pretty consistent result, especially in areas. This is in Quincy Here in Eastern Washington, Central Eastern Washington is a very hot area. So the heat stress here is very prevalent. Plus, those young trees don't have the root system yet all developed to support that tree. But you can see the response that keeping that stomata open, keeping those leaves functioning, keeping that sap flow, all the nutrition, all the things that Craig mentioned, that you're pouring on the soil, it needs to be taken. So by keeping that plant functioning, even if it's 30 more minutes a day throughout the growing season, is very significant. On this trial here, I'll share with you guys too, we did this similar, this is on cherries. It was the first planting, first year. There were satinas and lapins. They were done in California. We did 1% volume Parka applications. And we did 3 applications in this case. The majority of the programs now, to be honest, it will lay between 4 and 5 applications because it seems like our heat season is staying longer. So what we did on this one is we have NDVI image flown, and each of those dots is a tree, pretty much. On the left there, you'll see there's a lot of stressed trees. The reason for that, they have a drain canal where they dug there, and a lot of that soil got pushed into the block before they planted. So there's a lot of rocks and a lot of sand. So that portion of the orchard gets a lot of stress. But if you look at the control and the treated with Parka, they're divided horizontally. You see on the lappings there on the top part with this Parka, you see a lot more green trees. And the same thing happens with the satinas on the bottom. So again, you can see how those plants are functioning and performing better after the treatment. So we went farther. We talk about the nutrient uptake. We talk about the reserves. So we did tissue samples, and we measure some of those things like starch reserves. You can see, again, the increase on the Parka treated, very significant on the lappings. And then some nutrients like phosphorus and potassium also in some areas that Parka treated ones had better uptake of those nutrients. So we talk so much about the heat and the stress and how that affect, Craig mentioned fertility. We know, for instance, in cherries, in some varieties, post-harvest, you'll be in the hottest time of the season. Those trees are already stressed because of the harvest. And that's also bud differentiation time that will influence the crop for the next year. So in varieties that have issues like doubles and spurs, if you have a really stressed tree at that period, it's going to have a significant increase in double spurs for the next season. So on this trial, what we try to show is the increase of plant tolerance to the environment extremes by making those 3 applications of Parka post-harvest, enhancing photosynthesis, improving the tree health overall, increasing yield on the following season by reducing double and spurs. So we did 3 applications of Parka post-harvest in 2023, and then we harvest the fruit in 2024. So a couple of things that we measure throughout the season after those applications were made, chlorophyll content. So during the post-harvest, you can see this was done in Chile, so that's why you'll see that the time there might be kind of odd for the cherry growers here in the US. But as the season progressed and those leaves get older, you can see how the treated Parka held a better chlorophyll content on the leaf, giving that plant more tools to keep functioning, to keep it pushing. And you can see how that also had an effect on the stomata conductivity. So the Parka treated ones have a higher stomata conductivity throughout the season than the ones untreated. So then on harvest, that year wasn't a high incidence for doubles. They had a lot of incidence for suture, which is also related to the stress. But even then, if you look at the suture, we have 50% reduction, and the doubles, even though the incidence was low, the reduction was even higher. So there was a direct, benefit to that grower by helping mitigate that stress during that specific period of time that was so important. that carries through to the following season. So it's not always what we're doing now, but also what those plants are putting in terms of reserves, how they're setting the buds, and everything for the following season. So just to illustrate here, we have many recommendations. We can go over it with you guys. You can look up our website as well. But focusing on the heat stress and the things that we just mentioned here today, which is a small portion of the things that Parka can help. If we're looking in heat stress and sunburn, like Craig mentioned, starting after petal fall is very important to protect that fruit as early as possible. Depending on your crop and the spray volumes of water using, half a gallon to a gallon per acre. And if you're going a half a gallon, you repeat every 14 days. If you go a gallon, 21 days. And also, if you have heat events that you know is going to come, it's going to be really harsh, you can, make reactionary sprays ahead of those events to help the full program in case you need some extra, in case it has been, 2 weeks or 3 weeks interval there and you're stretching out those applications, you can make applications in between as well. And for the new plantings, again, because the volume water is a lot, most of the time it's lower volume than a full canopy trees that they're applying. Our recommendations are 1% volume in a minimum of 3 applications. And honestly, with the environment we have now and the conditions we're seeing, most of the time the programs are landing around 5, to be honest with you. But then we start with temperatures exceeding 85 to 90, and it's going to hold there for a few days. If you have 1 day or 2, those trees are not going to be so stressed, it's fine. But once you get those temperatures that trees that start shutting down and closing stomata and holding for that water, you can start the program and you can do, 14 to 21 days again, intervals. Thank you, everyone. If any questions, I'm happy to help.
Thanks, everyone. We do have some questions, and it looks like we might have time for 1 or 2. But first, as a reminder, for those who responded to the attendance notification for the CEU credit, please do not close your browser before the webinar has ended completely, or you will not receive the email with the QR code. This is also for the viewers watching the archived webinar. So let's see here. We do have some questions. Craig, this is for you. Do you think Parka helps to make it easier to wash off the surrounding residue from the fruit?
Okay,
Craig,
can you repeat that, please?
Yeah.
Yeah.
Do you think the Parka helps to make it easier to wash off the surrounding residue from the fruit?
I would probably say, just as a cursory view, yes, because you basically have put that sealant material on, which helps protect the rind. So I really never looked at it from that standpoint, but my guess would be yes.
Okay, and this looks like it's for Eva. How fast can the cuticle change in conformation? Thinking about environmental conditions varying during a growing season. If you have a sunny day that is hotter, is that going to affect the cuticle for the rest of the season?
Okay, if it's just a one-time thing, probably it will be unlikely to affect the cuticle for the rest of the season. But usually, what you have is changes of few days of high temperature or a few hours of high temperature during the day. And that causes a stress and a fatigue to the material that will eventually become weaker and more prone to cracking, losing water, etc.
All right. Looks like we probably have time for 1 or 2 more. This is for Tiago. Thank you for your talk on Parka. I do not know if this has been addressed yet, but when is Parka effective when applied? How many weeks before heat stress? Can it be applied in the middle of heat waves?
Yeah, like I mentioned, and we just learned how important that cuticle is throughout the whole season and how early that fruit can be affected by heat event. So the best recommendation is to actually have a program starting early and treated that fruit throughout the season. So then the fruit in the tree is conditioned to when those heat events happen. But like I mentioned, if you have an event that is coming and you need to get ahead of it, if you can get 2 to 3 days ahead, it's definitely going to have some impact. It's not as beneficial as the full program, but it will help you for sure.
All right. There was a second part to this question. How does Parka interact with drought stress? Does an increase in gas exchange during a period of drought stress mean that more water needs to be supplied to the plant to support that level of activity?
It not necessarily, because the plant will regulate as much itself. But when you don't have the micro crackings, when you have the micro crackings on the leaf, then the plant can regulate itself, right? Then they'll be losing water to the environment, and it cannot close and open stomata. If you have enough water, you're going to have a better use efficiency of that water, and the plant will regulate itself. If you really have a really drought, it might just need more water overall. But I think it wouldn't make it any worse. I think it will only bring benefits.
Okay, one more for you, Tiago. How does Parka fit into an overall crop protection or fertility program?
Well, when we're talking about nutrient uptake, we've got to talk about materials that are moved to the xylem, to the sap flow. If you have a tree that is stressed and that stomata is closed and there's no transpiration and there's no uptake, then that nutrient that you're putting out there is not going to be as effectively absorbed or taken by the tree. So if you have a plant that is performing at its best and is making use of the products that you put in there as a nutrient, and you have a better reserves going into the fall or into the winter to set the buds for the next crop, you have better starch reserves. Though all those things are going to influence the crop in the next season. And we have yield increase in some crops like nectarines, citrus, almonds, and things that validate our theory here with data sets.
All right, great. I would like to thank everyone for attending today's webinar. I especially want to thank Cultiva for presenting it, and a special thanks to our speakers, Antonio, Eva, Craig, and Tiago, for providing valuable information about the impact of rising temperatures on fruit production and how reinforcing plant cuticles can offer a powerful solution to heat stress, helping to safeguard plant health, yield, and quality in a changing climate. If you want to watch the webinar on demand or revisit certain parts, it will be archived and available at the same link you used to access it today. You will also receive an email reminder of the archive with the link tomorrow. Thank you again for joining us. This concludes the webinar.
Thank you very much.
Thank you.
Thank you.
Thank you.
Thank you, everybody.